In the previous lesson, we talked about compound inequalities that involved or. So it was one or the other. And then we used the little union symbol to say that the two were graphed on the same number line. In this lesson, we're going to talk about the and version of compound inequalities. Compound just because there's two. So if I've got an example here of x greater than or equal to -2, you'll see there it has the filled in dot, so it is or equal to. And then it is greater than, but then you come across this one with the open. So we would say, and at the same time, it's going to be x is less than 5. So if you think about this, it's really between the two, right? So sometimes that's the way we read that as well. The interval notation then, it's closed interval, closed set there on the left, and it's open on the right. Set notation, we do what we did up there for the inequality. So rewriting these, if you have the long version here, we often rewrite them. Like I said, between up above, you can write this as like that. So make sure that you can read that and see it goes the opposite direction. Forgot the 5 there. So x here, x is greater than or equal to -2. Now read this going back the other direction. So x is greater than or equal to -2. So it means the same thing there. So then we would also say x is less than 5. So x is between -2 and 5, and it could be on the -2 as well. So that's the condensed form. Now, if we're solving these, if they're written with an and in the middle, then I just solve them like normal. Like we did on the or, we're going to just have two separate equations. Here I can do 2x greater than -12. And then x is negative, whoops, not equal. X is greater than -6. On the other side, I'll add 2 and then divide by 8. Going to do equals again, not equals. So here x is greater than -6, but it's also less than 4. So it starts at -6 with an open circle. It's going to end at 4, also open, because neither one of those were equal to. And then I just fill in the space between. So interval notation on the left, it's open, -6 on the right, open with 4. Now, here's where it looks a little different. When you have it in the condensed form, we solve it all together, working inside out. Then we fill out the graph. Here's what we mean. So here I've got a minus 1 right there in the center. So to get a by itself, I need to add 1. But I'm not just going to add it to here. I also have to add it to the other side, because it's both of those equations. So I'm going to have, so that'll be -1 If you read that backwards, you'll still see A is greater than or equal to -1, and then it's going to be less than or equal to 7. So that would be A is between -1 and 7. Also, then we graph it on the line. They're both or equal to. So I can do a closed dot on -1, closed on 7, and fill in the space between. The interval notation, then they're both closed, so we have brackets. Now this one has more than one step. So I've got the middle part, -2 minus 10m. Now the goal is to solve for m to get it by itself. So the first thing I need to do, even though it's there on the left, is this is -2. I can add 2 to both sides. And remember, I also need to add it here. So instead of just writing it twice, you're actually writing it 3 times. So here's our inequality signs. So you need it in the middle and on each inequality. So now I've got 30. So m is multiplied by -10, so I need to divide. And I have to do it those other 2 places. So now I've got, remember the signs flip when I divide by a negative. So now I'm going to have, it's going to give me -3, and I have to flip my sign because of the -10 that I divided by. And then m, and then this one is flipped to less than. So then m is going to be greater than -3, open, and less than 1/2, closed. So open for -3, closed for 1/2.